Hello, thank you all for joining this talk. It's a pleasure to be here. And now we are going to see what has been done in Weston in order to add automated DRM backend tests in its test suite. First of all, I am Leandro Ribeiro. I've concluded my BSc in Computer Science last year. And in March of this year, I joined Collabora to work in an internship project in Weston. Before explaining the problem and what has been done to fix it, we're first going to give some background about the subject. In Weston, we have multiple backends that it can use. For instance, the X11 backend, it can use it in order to run as a X client. But it can also use the DRM backend. Weston's DRM backend can be used to make Weston run as a KMS user, so it will control the display pipeline and it will be able to use the KMS API to perform page flips and display its content in the screen. In order to make this happen, Weston needs to manage the DRM objects that can also be retrieved using the KMS API, and this is what we are interested in this talk. Here we have a display pipeline of a graphics card with only a primary plane available, and one thing to notice here is that as we have only the primary plane, Weston needs to compose the image using its renders. It can be GL render or Pixman, but the point is that Weston needs to handle this. And then it will be fed to a primary plane, and the CRTC will perform a scan out in order to put the content on the screen. Notice that if you wanted to take a screenshot using this scheme, it will be pretty easy as the composed image is already in the memory, and so we only need to save the file. Here we have another graphics card. This one has support for overlay planes and cursor planes and not only the primary plane. And the way that Weston handles the DRM objects is a little different here. First of all, Weston do not have to compose the scene using its renders. It will simply give the image to the appropriate planes, and the responsible for making the composition is the CRTC. CRTC composition is much faster, and this is the advantage that we have, but not every hardware has support for it. And in Weston, we need to see what's below us, for instance, a graphics card with only support for a primary plane or multiple planes, and we need to make it work independent of the hardware, but of course using what it has to offer for us. And one important point here is that in this case, as we are not rendering using the GL render or Pixman render, we cannot take a screenshot that easily because the composed image does not live in memory in this scheme. It only exists after the CRTC composition, but it's directly sent to the screen. So in order to if Weston wants to take a screenshot, it will disable plane composition. It will stop relying on the cursor and overlay planes, even if the hardware has support for it, and it will fall back to use its renders to compose an image and then feed this to the primary plane of the GPU. This happens until the screenshot is taken, and then Weston will start to use the planes again in case the hardware has support for this. Now let's state the problem that we had. In Weston, we have a test suite that runs automatically in GitLab CI, and we want to use it as much as possible in order to help to avoid regressions. And other point here is that the machines in GitLab CI probably does not have a display nor a graphics card connected. So how can we run DRM-backend tests using this setup? This is one of the problems. And the other, as we've seen, is that we want to test planes composition because, as we've seen, Weston have multiple ways of handling the planes. It may use only the primary plane or use the cursor and overlay planes, and we want to know if Weston is doing its job well. And the problem is that we've seen a few slides before that to take a screenshot, Weston will disable planes composition. And screenshots are very handy for testing purposes, as we can compare the output with an expected result. So how can we take a screenshot and taking into account plane composition in Weston? This is the other problem that we had. The proposed solution for the fact that we don't have a graphics card available in the GitLab CI, for the rendering part we don't have to worry. So for instance, if Weston wants to perform an animation and use GL calls, Mesa will handle this and fall back to software rendering options. For instance, LVM pipe, which will then convert GL calls into something the CPU can handle. And for the KMS API, which is the part that we are most interested and is the part that we've worked in this job, in this project, is that we can use VKMS. VKMS stands for Virtual KMS. It's a DRM driver and it implements only the KMS API, and we can run Weston on top of it. And it will behave like a graphics card connected to a display, and so it was made especially to be used by test suites. And we had to do some changes in Weston CI in order to run on top of VKMS. Here we have the scheme with the final results. So we have the GitLab runner machine that will start our Docker image. In the Docker image we have a Linux kernel image with VKMS enabled, and so we can use QEMU to start a virtual machine on top of this image. And so we can run our Weston's tests using VKMS. Here's the test suite of Weston running on top of VKMS. On the right side we have an animation test. So as I said before, Weston will use its GL calls that will be handled by Mesa, and Mesa will fall back to software rendering and convert to something that the CPU can handle. And the part that we are most interested is in the left side of this scheme, that is the KMS API. So Weston performs an atomic commit to perform a page flip, and this will be made using libdrm, and so it will be handled by VKMS. And we also had that other problem about the screenshots in the case that we have planes composition, and the solution for that is the usage of Writeback connectors. Writeback connectors are a special type of connector. Not every hardware has support for it, and it can be used to get the output from a CRTC after the plane composition and send it to the memory. So it's very handy for taking screenshots. And in VKMS, it's a virtual driver, so it does not have this hardware limitation, and the maintainers already are proposing a patch to add Writeback connector support. It's already in good shape and probably will be merged soon. In Weston, we also had to add support, and it's in a similar situation. It's already in good shape, but there's still a few comments to address. Here we have a scheme showing the Writeback screen shooter that we wrote for Weston. So it all starts in the screen shooter client that uses the Wayland protocol to talk with Weston. Weston will prepare an atomic commit with the setup for the Writeback job, and this will be handled by the DRM subsystem, and so it will perform this atomic commit and schedule a Writeback job for us. And it's important to notice that the Writeback job is not synchronous to the atomic commit completion, and so Weston will receive the page flip event. That means that the atomic commit completed, and now Weston needs to wait for the Writeback job completion. When this happens, Weston can get the buffer that the client shared and overwrite its content with the content of the Writeback. And so it will use Wayland again to tell the client that the screenshot is done. And the client will simply save the screenshot in a file. Here we have a picture with the Writeback screenshot. By the time that I took this, VKMS was not considering the alpha value of the cursor plane in order to blend the planes, and it was really cool for me because I could see that the plane composition was being taken into account in this screenshot, so it was really cool to see this square. And people in VKMS are doing a great job. There are a few patches already to fix this problem and consider alpha blending. That was all that I wanted to share. I hope you enjoyed this presentation. It was a pleasure. And I also hope that other compositors can use these ideas in order to enhance their test suite and add support for automated DRM-backend tests. Also, it's important to mention that how important Writeback connectors are, and that if your hardware has support for this, it's much easier to test plane composition and know if it's working good. In the future, Weston may be an alternative to take Writeback connector screen shooters and check if the plane composition is working well. And here we have the patches that we've mentioned in this talk. In VKMS, the patches that add Writeback connector support are already in good shape, but still didn't land it. But in Weston, we already have support to run the test suite on top of VKMS on GitLab CI, and the patches to add Writeback connector support and Writeback connector screen shooter still didn't land, though they are already in good shape. And that was all. I hope you had fun. Here's the summary of this presentation. If you have any questions, we'll be here to answer.
Okay. Hello. Is my microphone okay? Okay. Yeah, any questions?
So let's see. We seems like we have a couple of questions here. So which GPUs do support writeback connectors in hardware? Is this literally the equivalent of built-in frame grabber that really gives you what goes out of the video outputs?
Yeah, I'm not sure which GPUs exactly has support for Writeback connectors, but I know that Raspberry Pi 3 has support for Writeback connectors. Its GPU has support, but I'm not sure which hardware has support. And yes, I think that this is exactly the idea.
So the chat answers, it looks like Raspberry Pi seems to be supporting them, and Renaissance as well. Do we have any other questions here? Besides testing compositions, are there plans for testing further areas of KMS API? For example, hot plug events, error cases, and such.
Yes, the idea was to, at first we had to do a lot of job in Weston just to be able to have support for back connectors in first place, but we want to grow the test coverage as with the growing of functionalities in VKMS. That was the first idea. But yes, we want to have hot plug connectors and this kind of tests as well. Yeah, I can see that AMD or Dell don't support them. Yes, I tried to use it on my own graphics card and I was not able.
Yeah, they seem to rather have some kind of CRC capture and not like a full writeback. So if gamma sleuth or dithering is messing things up for me, I wouldn't see that without external grabber. So I guess that's a yes as well. Yeah, I think that the discussion is just going its own course right now, and there are no other questions, but people were really appreciative of your selection of background and like the environment you were presenting in, because, you know, the outdoors vibes. And like, it's really cool project to see. I'm really happy to see that VKMS is used in such a creative way, and like allows to test you the DRM backend. So I'm looking forward to other uses as well. So thank you for your presentation.
Nice.
And see you around.
Thank you.